Hello dear students, today we are going to see the chapter in physics, that is waves and its properties. This is for IGCSE and this is Mayank sir from the new Tulip International School. So first of all, in this chapter we are going to see types of waves. So there are certain waves that require medium for propagation. Those waves are known as mechanical waves. And another type of waves, those don't require medium for propagation, they are non-mechanical waves. So mechanical waves are actually creating vibration in a body or in a particle of a medium. So in a material medium and are transmitted by the particles of the medium vibrating to and fro. Such waves can be seen or felt and include waves on a rope or string. So these type of wave has one best example, that is sound waves. So sound waves, or we can say water waves, are these kind of wave. So any progressive wave, or we can say traveling wave, is a disturbance in medium. Remember this thing, wave is just the disturbance in a medium which carries energy from one place to another place. And there are two type of waves, transverse waves and longitudinal waves. Now first we are going to see transverse wave. So in a transverse wave, the direction of disturbance is at right angle. Remember this thing, that direction of wave and direction of disturbance are right angle to each other. Suppose you can see the diagram below, you can see that the wave is moving towards right while the direction of vibration is up and down. So that means both the direction are 90° to each other. So a transverse wave can be sent along a rope by fixing one end and moving the other rapidly up and down. So the disturbance generated by the hand is passed on from one part of the rope to the next part. So the humps and hollows of the wave travel along the rope as such part of rope vibrate transversely. Now describing waves, what are some important terms related to waves? That terms used to describe waves can be explained with the aid of the displacement versus distance graph. Here you have seen displacement versus distance graph. That means in y-axis you are taking displacement, in x-axis you are taking distance. So by the parts of the medium vibrating at different distance from the cause of the wave, first term is wavelength. Wavelength of a wave represented by a Greek letter lambda is the distance between successive crests. Now what is crest and trump? There are two things. Crest means the upward hip type of structure, okay, and the opposite is trump. Now between two successive crests, the distance is known as wavelength, that is known as lambda. You can see in diagram where lambda is marked. So that much is lambda, and lambda is actually, wavelength is measured in meter or centimeter or millimeter or micrometer. That means the unit of length will be used to describe wavelength. Now frequency, second terminology that is widely used, that is frequency, that is denoted by f, small f you can use, is the number of complete waves per second. So per second, how many complete waves you can generate, that number is known as frequency. Frequency is measured in hertz. Henry Hertz was the scientist. So in honor of him, we are using hertz as the unit of frequency. two waves are produced in this time, the frequency is 2 hertz. That means in 1 second if two vibrations are produced, that means frequency is 2 hertz. You can see below there are two different comparison given. So if the wavelength is smaller, then it is having high frequency, and if wavelength is longer, that means the wave has less frequency. So less frequency, more wavelength; high frequency, less wavelength. That means frequency and wavelength are inversely proportional to one another. Now another one point I want to discuss before starting this slide, that is time period. Time period is actually time required by one complete wave to pass through from one point. Okay, one complete wave require how much time? It can be in second, it can be in millisecond, it can be in microsecond. So that is known as time period, and that is described by capital T. Now what is speed? So speed of the wave is the distance moved in the direction of travel of the wave by a crest or any point on the wave in 1 second, that is speed. So actually speed has nothing changed in its definition, it is just distance upon time. Amplitude is again the important term. Amplitude is the height of the crest of the depth, or we can say the depth of the trough, okay, measured from the undisturbed position. Okay, that is known as mean position. The horizontal line, that is mean position. So any crest, okay, and any trough, we will find height and depth of these crest and trough respectively. Now we are moving towards the phase. The short arrows at A, B, C, D on figure 25.2 show the direction of vibration of the parts of the rope. That figure we have seen, the parts at A and C have the same speed in the same direction and are in phase. Now if two points are in phase, that means they are moving in the equal direction. Suppose the two parts in a rope that are moving upward at a particular time at a same horizontal position, then these 2 points are known as in phase. And if they are not at the same horizontal level and they are not moving in the same direction, okay, then they are known as out of phase. Now you can see here two type of graph. Very first graph is displacement versus distance graph, and second graph is displacement versus time graph. So what is the difference between these two graphs? Amplitude is same in both the graph, but whenever you are taking displacement versus distance graph, the distance between two crests is known as wavelength, while you are taking displacement versus time graph, then the distance between two consecutive crests is known as time period. So this is important graph. These two type of graph you will study, and many questions have been asked on the basis of these thing. We will practice those type of questions also. Now the derivation of equation, speed is equal to distance upon time. So you know that V is equal to D by T. So in case of waves, velocity is equal to distance is wavelength, so time period is T is time period. So we can say that speed is equal to lambda upon T. Now frequency and time period are reciprocal to each other. That means 1 by frequency is time period and 1 by time period is frequency. Again remember this thing, 1 by time period is frequency and 1 by frequency is time period, because time period is time required for one wave and frequency is number of waves in 1 second. So they are reciprocal function. So now what you will do, 1 by T is equal to F. You will put that value in the velocity equation. So it will become V is equal to lambda into F. and this is called wave equation. In many questions you can use this equation. Now the wave equation. So the faster the end of the rope is vibrated, the shorter the wavelength will be there. That means you are taking more time, then wavelength will be shorter, frequency will be higher. Suppose waves of wavelength lambda is equal to 20 centimeter travel on a long rope and 3 crests pass a certain point every second. So the frequency is 3 Hz, and if figure 25.3 represent these wave motion, then if crest A is at P at a particular time, then 1 second later it will be at Q. So distance from P of 3 wavelengths is equal to 3 into 20, that means 60 centimeter. That means the speed of the wave is 60 centimeter per second, obtained by multiplying f by lambda. So hence these formula comes true that velocity is equal to lambda into f, or we can say velocity is equal to f into lambda. Now wavefront and rays. So in two dimension, a wavefront is a line on which the disturbance has the same phase at all the point. Suppose you are standing opposite ocean, then the wave that is coming towards you, it is not actually a single wave, it is actually a whole wavefront. Okay, the disturbance has the same phase at all point, and the crest of waves in a ripple tank can be brought off as wavefronts. Now a vibrating source produces succession of wavefronts, all of the same shape, because in ripple tank you can see circular wavefront you can produce, and in a ripple tank straight wavefront are produced by a vibrating bar and circular wavefront are produced by a vibrating ball. So a line drawn at right angles to wavefront, okay, which shows its direction of travel, is called a ray. So here is the idea of wavefront and ray. There are two different terms but very important. Thank you students. You can contact me if any doubt further. Practice this session very well. We will meet you in the next session. Bye bye.